Hello, stat students. Welcome back. We're looking at ICA or practice problem 4-3. In this one, we're going to be looking at how to calculate standard deviation. We're going to be looking at doing it manually and then also using the Excel function to calculate standard deviation. Standard deviation, again, if you are unsure what it is, go back. I've got a couple videos out there on the additional web resources page in Canvas that you can look up and understand standard deviation, as well as the PowerPoint presentations that are there and your book. So make sure you understand standard deviation. We are looking at just a measure of spread of the data that we see. So let's look at how do we work through this. So part A says in cell C8, calculate the mean of the data points given in column B. So we basically just want to find the mean of this set of data, and we know that our function is average to find the mean of data, and then we highlight all the data that we have there, 17 through 13, close the parentheses, and we see that our average there, our mean, is 14. So part B, calculate the sample variance by completing the table below. Make sure to use absolute cell referencings in cells C12 to C17, show 2 digits of the decimal point. So in essence, to find the standard deviation, we've got to find the deviation of each of these data points from the mean, and then we have to square them. The reason is if we would add all these up, the deviation should equal 0 if we did it right, which tells us really nothing. So in order to find out what the standard deviation is, we've got to square the deviations, add them up, and then get rid of the square, find the square root of the variance. That's what we see. So in order to do that, to find the deviation of each data point from the mean, what we need to do is we need to subtract. So we hit equal 17 minus the mean. Okay. Now, one thing that we can do, we can use absolute cell referencing. One thing that's nice about Excel is we can just copy this formula. If we hit that 3 is a correct answer, so 3 would be the deviation. We could just copy this. We can highlight this little corner here and drag it down and copy. And what's nice about that is it copies the cell formula. However, if you notice, every time I move down a cell here, it actually moves the formula, the cells in the formula, down one cell, down one cell, down one cell, which is what we don't want. What we want to do is we want to copy this formula down, but we want to leave this cell, which is C9, we want to leave that set or static in our formula. So the way we can do that is we put dollar signs in front of the row and the column. We can either type them in, or you can actually hit F4 if you're running a PC, F4 or Command F4, I believe, in a Mac. That will do that. So what that tells you is what that you're telling Excel is if you copy this formula, you want to make sure that this cell C9 doesn't ever change when you copy it. So once we have that in there, now if we copy it, notice it will work for us. Right? We go back in here, we have 15 minus 14, which is what we want. We have 7 minus 14, which is what we want. So now we found the deviation of each of these points from the mean of the data points. And again, if we add this up, we can use our sum function, our auto sum function. Notice it comes up to 0, which tells us really nothing. So in order to find what the deviation is, we have to square all of the data that we have here. We have to square all the data we have to do that we have here. So the easiest way to do that is just type in equals, highlight the cell, and then you use the little caret, shift 6, little caret or whatever you call that, and that basically says raise it to the next power would be the second power. Square it would be raise it to the second power. So if we hit that, that would be 9. Now, because we only have these cells in here, we don't need to necessarily make anything static or use absolute cell referencing. So we can copy that down. And that gives us the squared that gets rid of the negatives, right? That gets rid of the negatives here. So now we have the squared. So now we can add them all up by clicking on the auto sum button, or you can type in the sum function. You hit enter. So that gives us the total of the sum of the cells, sum of the squared variations. Okay, now what we have to do here, this gets a little bit tricky. Now to find the variance, to calculate the variance, we actually have to take the total, take this 166, and we have to divide that by the number of the number of observations that we have there. Okay, so if we look at this, we have 1, 2, 3, 4, 5, 6 variations that we're looking at, but to find the variance, we want to take one less than that. So that would be D18 divided by 5. So our variance is going to be 33.2. So to calculate the variance, it's going to be 33.2. So your sum of all the squared variations divided by the number of observations minus 1. That formula is in your book. Now to find the standard deviation, we simply take the square root of this variance that we have. And there's a couple different ways you can do it. You can actually take this and raise it to the half power, 0.5. Or there is a function, a square root function, SQRT, square root function, in Excel, where you just type in square root and tell the cell to calculate. And that will give you a standard deviation of 5.76. Boy, that seems like a lot to go through just to calculate standard deviation. Well, you're right. And so we actually have functions in Excel that will give us the variance and the standard deviation of a set of numbers. And for variance, that is just simply VAR. And we just want VAR, just straight VAR. There's a lot of other variance functions. We don't need those. VAR, and we highlight all the data, close out parentheses, and there is our variance of 33.2. And standard deviation, same thing, ST, and we want STDEV, standard deviation. Again, we just enter all the numbers in the data set. In parentheses, we hit enter. And notice that gives us our standard deviation. So this is how you would manually calculate standard deviation. But what's nice is Excel will calculate it for you that way. So again, make sure you go and review what variance and standard deviation tell you and be able to do that before the homework and the test.